Welcome to the Rare Earth Exchanges podcast, where power, politics, and the world's most coveted materials collide. Rare earth elements power the backbone of tomorrow's most critical technologies. With China dominating global production, the U.S. and its allies must align strategically to ensure a stable future. This urgency prompted tech entrepreneurs Daniel O'Connor and Dustin Olson to launch Rare Earth Exchanges, a news and insight platform built to equip stakeholders and decision makers with the tools and intelligence needed to reduce dependency and build prosperous resilience. Let's get into it.
Everyone, welcome back to the Rare Earth Exchanges podcast. This week we got another special guest, Kalen Fitch from Gasbarre.
Yes.
Perfect. Thanks for joining us. You guys are out of central Pennsylvania. We were introduced to you through another group that we interviewed with Clearly Ahead and the
University, yep.
Yep. So we're super excited. So, Kalen, to kind of kick the conversation off, can you just share a bit of your background, how you got into this space, and then what you're currently doing for Gasbarre?
Yeah, thanks, Dustin. So, of course, my name's Kalen Fitch. I've been born and raised in central Pennsylvania, which has been a real pleasure. Most people don't know, but central Pennsylvania was the powdered metal capital of the world, and that's going to be important later in our conversation. That's also important how Gasbarre products started, which I'll touch on in a minute. So, I was in engineering and operations in various different industries in our local area, joined Gasbarre products about 3 years ago. I'm assigned to what is the Powder Compaction Solutions Division, where we focus on compaction presses and automation. Currently in a VP of Sales and Marketing role, but I share operational responsibility with our VP of Product Engineering. That would be John Jarosik. So the two of us kind of lead this division. Yeah, and it's for the past 3 years, we've been working on lots of different applications, but more recently became the subject matter expert for our company, I would say, on centered neodymium iron boron magnet production.
Fantastic. So, Daniel, do you want to kick the rest of this off?
Yeah, sure. I'd like
Great.
to just frame this that this is a very important discussion for everybody that's visiting, and we'll make sure we do articles on this as well. That the rare earth space, when people think about it, they think about mining. Much of what we see coming out of Washington is about mining and opening up, Greenland or Ukraine or whatever. And the fundamental problem is not mining. I mean, you always need supply, and that's important. But what's important here also is processing, refining. Much of that knowledge is locked up in China today, as well as magnet production. Again, much of that knowledge is locked up in China today. So this brings us to this topic today, and we're really down the supply chain into magnet production and the processes that go into that. So, Kalen, this is a very important topic. We'd appreciate if you could kind of share with us what's happening out there. Tell us a little bit about the company, how it got into this, and why things are heating up right now. This is the first point of this conversation.
Yeah, so just touching on the company, like I said, powdered metal capital of the world, 50 years ago, we started just building presses, furnaces, automation, ancillary equipment to support that industry. As things have moved along, that business has shrunk a bit. It's really tied well to automotive, the number of cylinders reducing, the EV shift. So we've had to diversify. So we're focused now a lot on emerging technologies and materials. Basically anything that's powdered material that you can compact, we've compacted. That includes some crazy things, to be honest with you, like people's ashes, clay pigeons. Those are the unique things. But more importantly, sprockets and gears out of iron and steel. Maybe it's dental inserts out of ceramic like alumina. Relevant to what we're talking about today, it may be iron, battery anodes, LFP, fuel cells, or centered neodymium iron boron magnets. We've been in that space or the magnetic space for a real long time. So ferrite magnets, samarium cobalt, alnico magnets, all of those, soft magnetic composites, all pressed on compaction presses, and our presses are used in those industries. So maybe not everybody knows, but over 90 to 95% of the centered neodymium magnets are produced in China today. So even more, if mining's 50 to 60% out of China, the magnet technology is really locked up. And the last magnet production facility, I think, was the Hitachi Metals in the early 2000s here domestically. I don't have to tell you guys, 25 years ago, A lot of those folks that were real good at making magnets 25 years ago are closing in on retirement or have already retired. So there's a bit of a workforce challenge as well. But ultimately, we can't keep buying magnets from what I'll say enemy states. Yeah, Daniel, you've talked a lot in previous podcasts about industrial policy and the need to work with our allies. We 100% agree. There's a lot of magnets that need to be produced, centered neodymium magnets here. I think Josh Ballard from USA Rare Earth said 7,000 to 50,000 tons per annum of magnets. I mean, we're talking millions of magnets need to be produced domestically, and we're just trying to be part of that. We thought we were a great fit for producing compaction presses to produce these magnets. Reason being is, and we'll talk a little bit about the technical aspect, I'm sure, in a minute, we have a thermal processing division where we build furnaces that need cover gas, whether that's nitrogen, argon, hydrogen, even endothermic gases. When you compact sintered neodymium iron boron magnets, you need to have a cover gas, generally nitrogen, sometimes argon. So we thought that would be the hard part. Little did we know there was a lot more fun to come with it. So we thought we'd be a great fit. We'd take our technology that we already have in compaction presses, translate the technology we have in our thermal processing equipment from our other division, and we'd be well along our way. So that's how we got started. 2020 is when we first started getting into this space. And really, just to kind of put a bow on the powdered metal piece, the companies that we initially aligned with were companies that either the people came out of the powdered metal space or they were already in the powdered metal space and looking to transition into centered magnet space.
That's very helpful and extremely important. So, on that note, you started 2020. Can you talk about, the changes you've seen in the last couple of years, how the demands are growing, and how you all are part of that supply chain fulfilling that demand? This is very important. Then we're going to get into more technical nuance and what types of support you all need, which is going to be very important.
Sure. Yeah, thanks, Daniel. In 2020, we had customers coming to us that were just looking to start magnet production. They were looking for laboratory pilot type presses, not super focused on throughput, but focused on flexibility and trying to make the best possible magnet for the highest grade that their customers were asking for. That's shifted significantly. And I'll say it shifted prior to the current administration and some of the trade policy that we've been working through. I think it's just a general recognition that we're too reliant from a supply chain perspective for magnets abroad, just loosely speaking. So we've seen, but really, that was customers coming to us and saying, "Hey, we really like your 30-ton lab press. Can we make a little bit bigger magnet out of that? We're not super worried about throughput. We're not going to make all the world's magnets, but ultimately, we need to make some more magnets." That's changed more recently in the past month or two with the trade policy. Now we have customers coming to us asking for quantities of 10 to 20 presses that are 3 to 5 times the size of the presses that we currently build. They need to produce a lot of magnets and they need to produce them fast. And they're being encouraged, I think, on the back end by various parties, whether that's an OEM or a government agency. It's just how fast can you get to your capacity as quickly as possible.
And that makes, sorry, go ahead, Dustin.
I was going to say, so that's interesting. So they're asking you to build things that you currently don't make. Is that a concern for you guys, or are you just saying, oh, we'll just create a new assembly line
Yeah,
and we'll
no.
just.
So, Dustin, in our space, capital equipment, that's not uncommon, actually, right? So,
Okay.
what they're asking us to do is scale a current product to be larger in size or higher in throughput,
Okay.
which
Right.
has challenges, but it's really a translation of technology, not starting from a blank sheet of paper.
Very cool.
And on that note, I mean, based on what you do, I mean, how many other companies in the United States are doing exactly what you do? Just so we can kind of have an understanding of the landscape. No need to mention names, but just what's that landscape look like for specifically what you're doing and where you're scaling up to? How dynamic is that supplier market?
Yes, domestically, there are other compaction press equipment suppliers. I'll say less than 5. Press suppliers that are producing compaction presses dedicated for centered neodymium magnet production or even capable on, and that's Gasbarre products in the
Wow,
US.
that's unbelievable.
Less than 3 in Europe able to produce that type of equipment. And China is a bit of an anomaly. They've had this need and technology for 20 some years now. So they have a fairly mature supply network, I would say. And we don't know how many presses, but there's multiple press manufacturers in China.
Right, right. But that's critically important. I mean, this is a fundamental service that's part of, it goes into the magnet production. And again, now there's a rule, 2027 rule about Department of Defense and defense contractors and procuring magnets ex-China by, I think, January 2020. I haven't seen anything lately about that rule. Do you, and only share what you can share publicly, but are you all getting orders from OEMs or groups that are working with defense?
Yes, of course.
Okay, good. No, it's good to hear, because I would imagine that's going to really have to change and grow domestically. And in terms of sectors, auto, energy, electronics, defense, can you are you diversified across all of those? Do you see, are there similarities, or are you seeing any differences, or pretty much uniform?
It's a really great question, Daniel, because, and there's a lot to it, actually. So just to step back, most people know, or maybe I shouldn't say most people in the space know how a magnet's described. So it's based on the strength of the magnet, which would be your remnants or maybe your BH max, and your coercivity, which is basically your resistance to demagnetization, generally associated with temperature. The Department of Defense and automotive applications need very high performance magnets. We're talking N45 or something to that range. The N45 would be the remnants or the BH max, and then the would be your coercivity. There's a lot of applications out there that don't need that high of performance and also don't need the high price tag that goes along with it. So there's some additional processing steps that you need to get into that high performance space, whether that's additional densification through maybe an isostatic press or heavier or content of heavy rare earths, which I'm sure you guys are very familiar with, the terbium and dysprosium, and grain boundary diffusion. So we're playing in all those spaces. I should say our customers are playing in all those spaces, the mid-grade magnets and then also the higher performance magnets. And we're working with our customers to try to be able to achieve those magnet performance grades, I'll say individually, and we don't have a standard product to get there necessarily. We have customized solutions that are helping each of those customers because they're developing their material system at the same time.
Yes, no, it's very exciting. I will say this: you're helping America become resilient. You're literally doing it right now as we speak, unfolding in real time. The question on this, and if you can't answer it, don't worry about it. But on the heavy rare earth side, let's face it, we just did our rankings. I don't know if you see our project rankings.
I did, yeah.
The Myanmar rebels, and by the way, they just joined our forum.
Great.
It's unbelievable. They sent us a nice note. In any case, the supply of that is pretty much 99% China. So do you see, given the last few months and sort of the constraints that the Chinese government, did you see any, how can I say this? I want to be politically correct. Were there any changes in heavy rare earth magnets over the last 3 or 4 months? Is it pretty much a standard behavior that you've been seeing?
So Daniel, not a lot of people in the U.S. are making centered magnets at this point.
Right.
A lot of them are in pilot scale. All of them were very aware of their risk factor related. At least I'll say all the folks that we're talking to were already very aware of the risk factor with the heavies. And each customer is approaching that a little bit differently, but each customer wants to reduce it as much as possible. I think is the easiest way to say it. And I haven't seen a shift in strategy or policy related to the export licensees and stuff like that. It's always been there, frankly.
Right. Yeah, it makes sense. That's what's really exciting about what you're doing. If you look at a question I do have is price. What we're learning, about this business, and one of the things we know is that industry is price sensitive, and traditionally, it's always a good feeling to be patriotic and to buy American, but there's also the realities of a marketplace environment and cost pressures. And based on your analysis, as we scale up in the United States, and I know it's still early days, how far off are we on pricing compared to some of these Chinese companies? Like, can we catch up with their economy of scale sooner rather than later?
I think I'll answer that in 2 ways because I think your question's on the actual magnet, but if you don't mind, I'll talk about the actual equipment.
Please, yeah, no, please. Yeah, that's part of it, yeah.
Quite frankly, even we can't produce a compaction press for the price that some of the Chinese suppliers are selling them for. So if domestic suppliers are able to or willing to produce Chinese presses, quite frankly, it's going to be a tough sell for whether it's European or American press manufacturer. Fortunately, there's a whole lot of risk that comes with purchasing one of those presses. I'll just give an example. Imagine trying to have one of those presses serviced, or imagine China decides for whatever reason that they didn't want to export that technology or knowledge anymore. Now you're sitting on a pretty expensive paperweight, potentially, right?
100%.
So we're not super worried about that. We think there's going to be a market and demand for our presses regardless. Now on the magnet side, it's interesting because we talked a little about the automotive space and Department of Defense, and maybe we'll call it industrial. And some people say the magnet in your blender that you make your smoothie in the morning, right? So I think in the automotive space, it's not, obviously they're going to go after the cheapest price, but supply chain risk is such a huge thing now. And that's post-COVID, whether it's chips or PLCs or whatever that would be, or rare earth magnets is the space we're playing in. So I think there are always those types of cost-driven consumers or customers are always going to be looking for cheaper supply, but they're going to need, maybe it's one additional supplier of rare earth magnets, or maybe it's multiple. Now, on the Department of Defense, of course, you mentioned the 2027 Act that will almost force it. It's ex-China. And
That's right.
Quite frankly, the European supply versus the American supply there's going to be cost parity there. And we'll never have cost parity with China unless China decides they want to have cost parity with the US.
Right, right. And that makes sense. And then there's other, I mean, Dustin, you had a couple questions about, other benefits of working, domestically, from, you mentioned some of them. It could become a paperweight. I mean, essentially you have more responsiveness, you have more security, you have flexibility. There's so many things that you guys can bring. Right. Especially, we now know, I'll just take a step back. The Chinese pulled the trigger on their export controls, and it's never going to go back to the way it was. And today, we know, we've heard directly from the horse's mouth, there are when you do access those rare earths now, you have to go through a process of sharing a bunch of information about everything that's going on. I mean, they're doing industrial espionage right now. Okay. It's an ongoing thing. Now, if you look at, let's look at the company and how we can help you, because I know you're growing, the sales are robust, but we need industrial policy. We need to be able to have companies like yours getting full support so that we can ramp up the ex-China market faster. Time is money, and we need some acceleration here. So talk about some of the areas where your company could plug and play into ecosystems federally that can help accelerate, not just for your business, for the magnet makers, for the OEMs, but for everybody, for our society. So what are some of the things that you think would be helpful for your company?
Yeah, and I might get a little long-winded here, so please just interrupt me if I
No,
get going.
please.
So we're a small to mid-sized company. I'm privately owned, and R&D is very difficult to fund R&D, I should say. We have 160 employees total. About 15 of those are engineers that are actively, 15 of the 80 that are associated with compaction presses are product engineers that are actively working on projects, customer orders that we have across all industries, right? At the same time, we're trying to develop new compaction technology for centered neodymium magnets and other type products, right? So we don't have a lot of bandwidth to just do R&D. So we're trying to fit that in. We really need a team that can, if we want to accelerate, and everybody wants to accelerate is the general message. We need a team that can dedicate themselves to developing that product that's going to be able to increase the throughput at the rates that they're asking for. I'll say the market is they. Centered neodymium magnet pressing is very difficult. To start, I mentioned you need to do it in a cover gas. We haven't talked about the actual how it's done, but you need to have electromagnetic coils or electromagnet coils in the general die space. You can't use a compaction press that you would use for standard powdered metal because there's just not enough space. So you're putting these large coils that you're going to use to align the particles when you actually do the compaction. The powder is really unique, 3 to 5 micron in size. Very, very fine. An example, something similar might be if you took a handful of baby powder. So
Wow. Yeah.
The really neat thing about it, if you like fireworks, is it's pyrophoric in oxygen. So when it's exposed to oxygen, it catches on fire.
Wow.
Starts to smolder and catches on fire. That's why it needs to always be under this nitrogen cover gas. Those are relatively easy things to cover. Can you imagine trying to flow or pour baby powder into, say, a 1x1 inch die? It just doesn't want to flow into that die
No.
space, right?
Yeah.
So all of these things need to be solved so that we can actually produce a press that makes magnets. And we've done it. So we've had these 30-ton presses that are out in the field today making magnets, making good magnets, quite frankly. But what we found is our customers, they don't know how to make magnets either. And if you listen to some folks, there's some really, really intelligent people out there in this space, but they're learning the same time we are. And whether that's at the strip caster or the hydrogen decrep furnace or the jet mill, they're trying to apply all these resources at the same time we are. So we've been forced to really lean into the process. We would love to just sell a machine that has a 0.5 or 1 Tesla field between the two coils and say, go ahead and make magnets because everybody else can. But our customers just aren't there yet. We offer service and support where we're actually helping them work through their powder flow issues. We're trying to maximize the magnetic flux. You're really trying to get somewhere around 2.5 Tesla maybe through your magnet while you're compacting. That requires some really unique tooling approaches. You can't use standard powder metal tooling. It's a optimization of permeabilities. All this technical know-how needs to be developed, and you can translate some from existing knowledge, but it really requires an R&D effort. And if we want to speed up, it's going to have to pay for that somehow. And right now, Gasbarre is footing the bill.
Yeah, and that's a very important point. And I've heard exactly what you said and expressed in different terms to different stages of the supply chain for rare earth product generally. So this is where some form of industrial policy comes into being. Now, I can tell you the new bill that was just signed, there are fundings for stockpile and things like that. Not enough for what we're talking about here, although there's a substantial amount for loans that have to do with the process. So I think, now do you see, let us say we could get interest with the federal government for funding R&D in this area. Do you see this as a consortium, like, for example, yourselves, other companies in the supply chain that come together and some sort of pool things? Or do you see this as more coming out of your firm with grants where you can hire, a team? Do you see this more as an external collaboration, ideally, or an internal effort where you can staff up 5, 10, 15 people? How do you see this ideally?
I would say, Daniel, that we're open to different ideas. Of course, there are programs out there that help, and I'll say the R&D tax credit program is one that we take advantage of. But I'm speaking from the perspective of compaction presses, but the real magic's at the strip caster when you're making magnets. So we're aware of companies in the U.S. that are starting to build capacity and the ability to produce that equipment domestically. They're in the same boat we are, though. They're relatively small companies that are trying to develop a brand new product line to support a demand that's really driven by a domestic need and really vulnerability we have from a defense perspective. So there's a bit of patriotism to it.
Well, there 100% is. It's no joke. It's very, very serious. Now, on that note, I mean, and again, you may not be able to answer this, and that's okay, but what's the amount of capital, if you had to guess? Just think of it about it in people. Like, imagine there is an R&D effort that was being funded. What would be, of course, it's a hard question to ask, but what kind of scale do we need? Do you imagine we need, 20, 30, 50 engineers looking into these things? Is it 100? Is it 1,000? Is it 5? To try to put some parameters around short to intermediate term, if we could get funding, what does this look like?
Yeah, it's an interesting question because it depends on what the ultimate goal is. So to give you some perspective, low end, I think we imported 7,000 tons of magnets last year. A single 150-ton press is what we're currently working on right now for a couple customers. It's going to produce 90 tons per annum. So just put that into perspective, how many, 50 some 60 presses you're going to need just to produce the low end if you want to do that full magnet production that we imported last year. But of course, we're not going to import the same 2030, 2035. That number is almost exponential in terms of what we're going to need to produce. And maybe that's 50,000, maybe that's 30,000. So the effort's going to be, there's kind of two parts. One is developing the machine, but there's another part on how do we develop enough machines. The throughput that we have today on our fastest equipment is not going to be enough. The market's not going to support purchasing 60 presses.
That's right.
To give you some perspective, we supply maybe 10 to 15 presses per year across all industries.
Right. Yeah. No, this is very important points you're raising. Very, very important. Dustin, we have a few other questions I think that can flow from this. This is great, Kalen. Really incredible information. Dustin, do you want to pick up on a question or two, and then I can kind of start to help us wrap up?
Yeah. So to kind of piggyback on the conversation we're having right now is there's a certain level of complexity involved, right? And money's required. And we've talked about this with other guests that we've had on the show. Daniel and I have talked about it on our podcast here. But in terms of time, what does the runway look like just to deliver what your customers are asking for, to even reach a level of production that's required, independence from other countries? And I'm asking this question because I think a lot of us, it is 2025, we're very fond of instant gratification. There's probably a misconception that some of this can just happen overnight or happen within a year. We just don't think that's true. So can you give us an idea of what that looks like?
Yeah, so generally for a new piece of equipment like this, it's going to require some engineering. It's going to be somewhere between 8 and 12 months. And then, so we here at Gasbarre Products, we do all of our own production and fabrication, machining of our components. So we're really very vertically integrated. What we can do is start stacking machines every 2 months from that point forward. So we're able to produce, call it 6 machines a year if we had the orders to do it, and we would be able to just keep spitting out 6 machines per year. Of course, we could always increase capacity. It's a matter of just manpower and space to put those pieces of equipment while you're assembling them, so you could do 2 or 3 at a time. The R&D effort to get to scale the current systems that are available is I'll say relatively short. 2 to 3 months, 3 good engineers could probably put together a system, and then you'd have to stack on some debug and testing on the back end of the assembly. The R&D effort to come up with a process that's going to be able to produce a lot more throughput in this, so instead of 90 tons per year, if you wanted to get to 200 or 500 tons per year, I think that's going to take some engineering and back to first principles, and that's going to be a lot tougher problem to solve. The short-term solution is and Gasbarre is going to do it regardless. We're just going to keep banging out presses, and they're going to make good magnets. It's just it might not be optimal for the overall market when it gets to 30 to 50,000 tons per year.
That's correct. And speaking of time, looking forward into the future, 3 to 5 years, where do you see things headed? What's your prediction on just this market expanding? Yeah. What are your thoughts there?
Yeah, that's actually a good question. We know it's going to grow significantly, and I haven't really dug deep into what all the levers are because there's so much momentum right now. I think there's going to have to be some probably consolidation. There's a lot of smaller players out there in the market today that are just getting into the space, coupled with a handful of bigger ones, and you guys know those names, which of course we've been working with those folks as well. So maybe you'll see some of that, but I think the growth is going to happen, maybe not as fast. And I do think our sensitivity to price is going to lead some customers or OEMs to continue to try to purchase from China if China allows that. And my general feeling from the Chinese perspective is they really want this industry because they want jobs. If you look at the 2035 directive, they don't want to cut us off and then cut themselves off from demand. America's still a big customer. Like you said, Daniel, industrial espionage and things like that, if they leverage those types of tactics, that might limit the demand for their products. But ultimately, growth. That's if I could summarize that in one word, Dustin.
Yeah, and I was just going to say, for China, they use market structures as tools for accumulation of capital and power. But it's a very different mindset. It's adversarial fundamentally. It is a zero-sum game in some ways. And right now, it's not looking good for us. We have to change it. I was going to say the typical way that, collaboration happens, conferences, universities, you have partnerships, there's networks that form around R&D efforts. But ultimately, I feel like your company needs support to build a center of excellence right in the company and then, help influence bringing that entrepreneurial ethos radiated out to others and then build a network. We need to try to help you build that R&D capacity. And I'm hoping that people that listen to that are watching this and we'll write about it as well in Washington understand this, because what you all are doing, this is where the rubber hits the road, ultimately, the magnets, right? And there's other components and assemblies, but this is where the rubber hits the road. So if we can't overcome this, and we will, we're gonna be in a big trouble. So I think we'll, as part of Rare Earth Exchanges, it's our mission to help accelerate the ex-China market. Okay, we happen to be in the United States, so we have an American-centric view of the world. So we'll definitely be in touch with you about how to help you build out R&D capacity organically.
Daniel, if you allow me to plant one seed here on that center of excellence idea, and this is because I'm a little bit of a homer, but the technical know-how, the support industry to produce centered neodymium magnets exists all in central Pennsylvania. We have tool shops, we have powder metal folks. We talk about density of green compacts at dinner with our kids, and we underestimate how important that is.
Yeah.
Really, it's in our blood up here. So I'm surprised that more folks, as the powdered metal industry consolidates and compacts, and contracts, I should say, I'm surprised they're not trying to get into this space, because we have the die setters for the compaction presses. We understand the thermal processes that are required. So there's no better place than central Pennsylvania for a center of excellence.
And by the way, it's not by accident that we sort of arrived in central Pennsylvania, right? That's on our mind for sure. That's going to be a cluster. That is going to be a center of excellence within the United States. It looks like very much like it could be. So let's make it happen. I would say, let's go ahead and make it happen. We'll be part of the solution, and we'll look back 5 years from now and say, look where we're at now, surpassing the Chinese or approaching them.
Yeah,
Dustin?
that's great. So, Kalen, if you could, just to help summarize, put everything into perspective, or even possibly share what you're most excited about with the work that's happening now and where it's headed.
Yeah, I think the most exciting thing for me, Dustin, is we're getting through the pilot stage of magnet production in the U.S. There's lots of folks that have made a handful of good magnets. We'll say thousands of good magnets. We're ready to start making millions of them now.
That's awesome. And we're super excited, and we're honestly, I'm stoked with the work you guys are doing and what it means for us as a nation and as a global community as well. So
Yeah,
with yeah, go ahead.
Dustin, I just want to take an opportunity to thank both you and Daniel for what the work you're doing with Rare Earth Exchanges. Super interesting. I can't even keep up with all the press releases, but also thank you for giving us this platform to discuss the actual production of magnets.
Absolutely. Yeah. And we would love to have you on the show again in the future, just to get an update on where things are at and how things have grown and improved. But with that, I think we'll sign off here, and thanks for joining us. We really appreciate it.
Yeah, thank you guys.